Welcome back to Hate Sparsh. Today's problem of the day is partition array according to given pivot. So here, let's just check the problem statement. We are given a zero index integer array nums and an integer pivot. So we are given an array nums and another integer pivot. Let's say x. We have to rearrange nums such that the following conditions are satisfied. So let's go through the conditions. What these conditions are: every element which is less than pivot appears before every element greater than pivot. So we have to rearrange nums so that a value, let's say there are value a comma b comma c comma xyz. So let's say if xyz is less than x is less than x, then in the array it should appear like x comma y comma z comma we can take this pivot as instead of just getting confused it with x only, we can take this pivot as m, or let's say p, and every element greater than pivot. So let's say a b c are greater than pivot. So a comma b comma c are greater than pivot. So a comma b comma c can appear here. So this first condition can be satisfied, and every element equal to pivot appears in between the elements less than and greater than pivot. So what does that mean? That these are the elements which were less than the pivot and these are the elements which are greater than pivot. So every element which is equal to pivot, so that means that inside nums there can be elements which are equal to pivot also should appear in between the less one and the greater one. And hence how our array will look like: x comma y comma z comma p, there can be multiple p's, and a comma b comma c. So this condition will also be satisfied, that all the elements which are equal to pivot should appear in between the elements less than pivot and the elements greater than pivot. And the third condition is the relative order of the elements less than pivot. So relative order is, let's say pivot occurs somewhere, let's say it occurs here, p comma a comma b comma c, then p, then xyz, the order is maintained. So let's say if we are rearranging these elements and we know that okay, x comma y comma z is less than this, then this should be the answer. And let's say if we want to write it as y comma z comma x comma p, then this is not a valid answer, because the relative ordering which is present inside the actual array xyz is not maintained here. It should be x comma y comma z. So the problem is pretty simple, and what we need to return, we actually need to return the nums after the arrangement. So this is a zero based index array which is given to as nums, and we only have to return nums after the rearrangement. So we are also clear on the part how the rearrangement should look like. Now let's just dive deep into one of the example. So let's say we are given this array example. I'll just write it down for you: 9 comma 12 5 10 14 3 and 10. And what the pivot is given to us? Pivot is given to us as 10. Now what we need to do, we need to find out any elements which are less than 10 should come on the left side of the array, and any elements which are greater than 10 should come onto the right side of the array. And between the less than and the greater than elements, we have to put the equal values. So if we traverse the array from left to right, we see that okay, 9 is less than 10, we can put it here, but 12 is not less than 10, so we need to place some gap in between, and we will put 12 somewhere here. Then we come out and see that 5 is again less than 10. We'll put 5 here, and then we found out 10. So 10 can be placed somewhere in between smaller and greater than elements. Again, similarly, if we'll see 14 is greater than 10, so after 12 14 will come, and 3 is less than 10, so 3 will come before 10, and another 10 is there, so we'll add 10 here, and hence we are now seeing that this is the required answer. If you'll see 9 5 3 10 10 12 14. So I believe you guys must have understood that how we should be rearranging the solution. Here you must have noticed one thing, that we have placed 9 at the first place, 5 at the second place, and 3 at the third place. We have not changed the order anyhow. We have maintained it as 9 5 3 only, and not 3 5 9 or 3 9 5. So let's just also look at the constraints. The nums length, basically this array length can range between 10 raised to 5 to 1, and each value which is present inside this array, like all these values can range from minus 10 raised to 6 to 10 raised to 6, and pivot equals 2 and O. So this is already given that pivot will occur at least once inside nums, because it is equal to whatever element is present inside nums. So at least once the pivot will come. Now, what is the intuitive solution which one can think? So what we can do initially is, let's say I am given this array. Let's take this array only, 9 12 5 10 14 3 and 10. What can I do here? I can create two more arrays. Let's say less than pivot, and one we can say more than pivot. And what I can do, I can run a for loop for this specific array, and if I'll find any element which is less than this, if I'll find any element which is less than the pivot, then I'll put it in less than pivot array. If I'll find any element which is more than pivot, then I put it in more than pivot array. So what, I'll just iterate over this. So 9 is less than pivot, 12 is more than pivot, 5 is again less than pivot, 10 is equal to pivot, then I am not maintaining this value anywhere. Similarly, 14 is more than pivot, 3 is less than pivot. So now our arrays are complete. So what we can do now is, we can just go through this nums array once again, and what we'll do, we'll just copy paste these elements on top of whatever is present here, because now we have less than pivot, more than pivot. And how are we going to calculate the number of elements which are equal to pivot? So you can see that our nums dot length is 1 2 3 4 5 6 7. This is 7. Less than pivot is 3, and more than pivot is 2. So our total elements which are less and more than pivot are 3 plus 2 equal to 5, and total elements which were present in the original array were 7. So we know for sure that 7 minus 5 equal to 2, which is the number of elements which are equal to pivot. So this 10 and this 10 here. So now we are just going to rearrange. So now how will this array look like? This will become 9. This will become 5. And this will become 3. And after that, as soon as we'll exhaust the pivot array, we have this value that we need to enter pivot 2 times. So what we'll do, we'll say that pivot is 10, 14, we'll replace it with again 10. And now we have exhausted this two value. Now what we'll do, we'll go like and replace all the elements with more than pivot value. So this will become 12 and this will become 14, and hence we'll get the answer 953 10 10 12 14. 953 10 10 12 14, and hence we are able to solve this solution. So just going through the code, we have these two vectors and we are just iterating over them. If value is less than pivot, we are adding it in less than pivot. If value is greater than pivot, we are adding it in array greater than pivot. And we are now just taking two elements I and j, where j is keeping the track of how much nums we have filled till now, and I is keeping the track of less than pivot or greater than pivot. So nums j is 0. So nums j, basically nums 0 equal to less than pivot, whatever element is present in less than pivot. So here 9, then 5, then 3. After that, what we'll do, we'll again reset I equal to 0. And now what here we are doing, we are seeing nums dot size less than pivot ka size and greater than pivot size. So what this value is giving us, this is giving us this value 2, which means that these many elements are the elements which are equal to pivot. And hence we have added these elements in the, like, we have added this in the array as value pivot only. Similarly, we again now just made j plus equal to I, basically just forwarding the element how many times we have filled the pivot, and then for greater than pivot we are just pushing these greater than pivot elements. So now here what you can see, here we can see that we are running this for loop one time, so which is on. Here we are, and less than pivot and greater than pivot, how many elements can they contain? So let's, the equal to pivot can have a minimum of one element. So less than pivot, if let's say we can say all n minus one elements come inside this, so this can take at most n, this can take at most n, or this can take at most n, but we know that sum of all these three will not exceed n. So here what we'll see, that the time complexity which we are consuming is O of n itself, and space complexity which we are taking is also O of n, because we have two vectors which is less than pivot and greater than pivot, and both the sum of the both will also be come to n only, because they're like these two vectors cannot contain more than n elements, because our nums only contain n elements. And hence we see time complexity is O of n, space complexity is O of n, and yeah, that was all. So here how many passes did we take? We took this first pass, and then the answer which we have taken a second pass. Now in an interview, what will the interview say? That okay, you have taken two passes, but can we somehow reduce some memory, or can we reduce some time complexity? So you know that time complexity anyhow we cannot reduce to less than n, but we know that the problem itself asks that we need to return nums. So what we can do here is, what we'll say okay, we'll take another array which is, let's say, O of n, like we'll take another array, let's say answer, and this size is O of n. So the space complexity will become O of n, but the auxiliary space will become O of 1. So for that, what can we do? Basically we can take now two things. One is number of elements which are less than pivot, and number of elements which are equal to pivot. And now we'll just use one loop where what we are going to do, we are just counting these elements, that how many elements are there which are less than pivot and how many elements are there which are equal to pivot, and we got the count here. Now what we'll do, we know that in an array where we need to do the arrangement at index 0 till index number of elements less than pivot, let's say this value is number of less than pivot, till this element, so this segment will contain all the elements which are less than pivot. So we at least got our pointer fixed that okay, from 0 to number of less than pivot elements, like less than pivot elements will be less than pivot itself. And then from number of, like from index number of less than pivot to index number of less than pivot plus number equal to pivot, we can say that okay, now these elements are the value which are equal to pivot itself, and accordingly the last portion of the array will contain all the elements which are greater than pivot, and hence the solution will look to you somewhat like that okay, we have one pointer, this is the second pointer, and this 0 is the third pointer. So we are first, second and third pointer, and by fixing these pointers we know that okay, whenever we are encountering any element inside nums, if it is less than pivot, we'll add it inside first array, and we'll increment this count 0 to 1. If we, let's say, find any element which is equal to pivot, we'll just put it at num less than, like here, and then do it plus plus and just increment the count. Similarly to number equal to pivot plus number equal to less than pivot, we'll add it here and we'll do plus plus. So basically we know that okay, like from index I to j, this belongs to less than pivot, this belongs to pivot, and this belongs to greater than pivot. So here we have taken initial index 0, which is this, equal index to num less than pivot, and final index to num less than pivot plus nums equal to pivot. So these are basically, you can say, 3 pointers which we have taken here. And now again we are traversing this nums, and we have taken an answer here, and answer have a size, and we have fixed this size. So whenever we are finding value is less than pivot, we are just adding it at initial index plus plus. Initial index is what? This 0, and we are incrementing it from 0 to 1 and putting the value at 0th place. Similarly, if we are finding any value which is equal to pivot, we are adding it at number less than pivot, this basically equal to part, and hence we are increasing the value like by plus plus, and we are adding the pivot here. Similarly, we are adding it at the third element whenever the value is greater than pivot, and hence our problem is solved. So in this case, what do you see what we are actually doing here? The answer is taking space complexity of n, but if you are asked about auxiliary space, it becomes O1. Also, if you'll see that time complexity, what we are doing, we are traversing this array once, O of n, and here you can see we are again traversing this array another time. So the number of operations in first and the second approach is approximately the same, which is O of n itself. Now what the interviewer can ask you, that okay, you are passing the array 2 times in both of your approaches, you are passing the array 2 times. So is there a way you can only traverse the array a single time and can achieve the answer? So what we can do now here is, we can say that okay, we can do it, and we can do it with the basis of 2 pointers. So what we can do is, let's say this is our array, this is the initial index, or we can even say it's starting index, and this is the final index. Now when we are traversing the array initially, like when we are traversing the array, we know that initial index will start having the numbers which are less than pivot, and final index will have all the numbers which are greater than pivot. So these are less than and these are greater than. So now what we are doing, we are still taking another array which is answer. We'll take, this is the nums which is given to us, and we'll take another array answer, where we know the initial index is this, final index is this, initial index is this, final index is this. Now we are traversing nums, and now we are traversing nums from both the side. Basically, initial index and final index, we have two more elements, like basically I and j, and I points to starting and j point to end. So let's say we are traversing, if I nums of I is less than initial index, we'll put it here, like nums of I, whatever element that is, we are putting it here. Now we'll just make this initial index move one place forward. Now it will point to place 1. Similarly, for final index 2, if we see that, okay, find nums of nums of I is greater than pivot, then we know from the last, nums of I is basically nums of j, sorry, this, like, just a small correction, nums of j is greater than pivot, then we know, okay, this is a element which is greater than the final index. We'll put this here. So what we are doing, in a single traversal, we are putting these value nums I, like elements which are less than pivot. Let's say pivot comes in between. So before pivot, we are adding elements which are less than pivot, and after pivot, we are adding elements which are greater than pivot. And hence, what will happen? We'll reach to a stage where I will come to n. I will now here, I will be here, and j will come here. So what will happen? I has traversed whole array, j also has traversed the whole array, and we have gathered our elements sequentially, like nums I from initially and nums j from backward side of the array. And this initial index and the final index, what do these two things hold? Initial index will now be at here, some point here, waiting to be written, and final index will be some point here. So the value between initial and final index is still the random values which is present inside the answer, like array which we have taken. Answer, like by default it will have value as 0 0 0 0, whatever, how many zeros can it be, and we need to now put it, like we need to make it as pivot, like we need to make it equal to pivot. So what we'll do, we'll take initial index, like initial index, and run a while loop on it till it reaches final index. And we know final index is also the element which is not at the nums j, like which is not greater than pivot. So we'll make it less than equal to, and for every value we'll just make this nums of whatever we can take, nums of I equal to pivot. So here what you see, that we have traversed the array only once, like in a single pass. So like we have traversed the array both, like from left and right side. If you will see, we are traversing it 2 times, but we have traversed the array in a single pass, that means in a single for loop. And apart from this while is also being running from initial index to the final index. And hence, using this 2 pointers approach, we have not used we have not traversed array 2 times, and hence we again like have achieved like whatever the interviewer was asking us in the like best method possible. So just walking you through the answer, we have this n as num size, initial index, last index. Initial index is 0, last index is n minus 1, which is the last of the value, this answer. And for int I equal to 0, j equal to n minus 1, you can see these are the constraints which we usually define to traverse an array. We are checking that if num size is less than pivot, then we are doing initial index plus plus and assigning num size to it. Similarly, if nums j is greater than pivot, we are subtracting, like reducing the last index from this place to this, similarly like backward, and assigning the value as nums j. Now when we have this value in the answer, like what I have told you here, that answer is already sorted here, like this thing is sorted and this thing is sorted. Sorted means that all the value less than pivot is now on the left side, all the value to the like greater than pivot is on the right side, but the element which are between initial index as well as last index are still 0 due to this. So we have just taken initial index plus plus like till last index, and we have marked them as pivot, and then we'll just return the answer. So here what we'll see, the time complexity is, this is O of n, and this is also like total sum will become O of n. So this is O of n plus something less than O of n. So time complexity will be O of n, but this sum will be n itself. And for the space complexity, if you'll see, we have taken only space answer, rest are O1 constant space complexity. So space complexity is O of n, but as we know that we need to return the answer. So if you'll see, auxiliary space here as well is O of 1, and hence we have reduced our problem from the initial approach, which was basically just maintaining two arrays, maintaining O of n space complexity and time complexity, traversing the array in two passes, to just maintaining time complexity of O(n), auxiliary space of O1, and traversing the array in a single pass. That's all for now. Thank you.